Good morning, everyone. Mr. Cortina here. Happy Friday. Today's April 17th, and today is just going to be kind of a review day with our word problems. So this is going to involve everything we've been working on all week and the last 2 weeks. Keep in mind, watch me. You're going to work with me, and then you're going to work on your own. Today's target. I can solve problems involving fractions and mixed numbers. Again, this is stuff you've been working on all week. It's just going to be a different format, and it's going to look like word problems. Let's remember our strategy for solving word problems is to mark up the question, create a title, and then solve. So we're going to start by reading the question first without marking up. And the question says, Taylor drank 3 2/3 cups of water on Monday. Justin drank 4 1/4 cups of water on Monday. How many total cups of water did they drink? Alright, let's go back and annotate. Remember, we underline actions and questions, and we circle numbers with labels. Taylor drank is an action, 3 2/3 cups of water. It's a number with a label. We're going to circle it on Monday. Justin drank 4 1/4 cups of water on Monday. Another number with a label. How many total cups of water did they drink? So our question is asking how much total cups of water. So that's going to be our title for our problem. Total cups. That's what we're looking to find out. We're going to bring down our information from above. Let's change up the color here. So it says Taylor, and mark her with a T, drank 3 2/3 cups of water. Justin, I'm marking with a J, drank 4 1/4 cups of water. We want to know the total number of cups they drank together. So what does that mean? Correct. We are going to add. Alright, this looks just like the problem we had yesterday. We're going to add mixed numbers with different denominators. So we're going to start by decomposing our mixed numbers. So over here, Taylor has 3 whole cups plus 2/3 of a cup. And Justin has 4 whole cups plus 1/4 of a cup. We're going to start by adding our whole numbers. We have 4 plus 3 gives us 7. Okay, hold on to that piece of information. We're going to need that later. Now we're going to look at our fractions. We'll do this over here so we have a little bit more room. We have 2/3 plus 1/4. You should notice that we cannot add these right away because, that's right, we have different denominators. We need to make these denominators the same before we can add them. So we need to find the least common multiple of 3 and 4. Just going to list them out. You can skip count in your head. Stop there. And it looks like we found one. 12 and 12. So our new fractions are going to have 12s in the denominator. We're going to write those right below, just like yesterday. How did we get from 4 to 12? Multiplied by 3. Do the same to the top. 3 times 1 is 3. How do we get from 3 to 12? Well, we multiplied by 4. Let's do the same to the top. 2 times 4 is 8. So we have 8 twelfths plus 3 twelfths give us 11 twelfths. I recognize this number from a problem we did a little while ago, and I realize that it cannot be reduced or simplified into any other fraction. It is 11 twelfths. Our last step is to go back to the first part. We have our total over here, 7, and we're going to combine it with our fraction over here, 11 twelfths. And when we have a whole and a fraction, just like we decomposed up here, we can just bring them back together, 7 and 11 twelfths. Alright, so very similar problem we've been working on. The only difference is we have to pull the information out of a word problem. Let's practice one together. Remember, we're going to read first and then annotate. It says, Brian ate 3.5 cookies after lunch. Joseph ate 1.5 less cookies than Brian. How many cookies did Joseph eat? Alright, let's break it down. Brian ate, action, 3.5 cookies after lunch. 3.5 cookies is the number with the label. Joseph ate 1.5 cookies less than Brian. How many cookies did Joseph eat? Okay, so what are we looking to answer? We don't want to know how many cookies Brian and Joseph ate. All it's asking us for is cookies that Joseph eats. So we're going to title our problem Joseph's Cookies. And that's what we're going to try to figure out. It tells us how many cookies Brian ate. Brian ate 3.5. Joseph, however, ate 1.5 less cookies than Brian. So this is telling us that he didn't eat 1.5 cookies. It says he ate 1.5 less. So whenever you see that word less, what should we be doing? Adding or subtracting? That's right, we're going to subtract. Less than means we subtract. So we're going to follow our same process for adding and subtracting mixed numbers. We're going to start by decomposing each mixed number. So we have 3.5 is 3 plus 1/2 minus 1 plus 1/2. Right? So for subtracting, remember when we subtract fractions or mixed numbers, we're going to start by doing the fraction first in case we need to regroup. A little bit different than the addition. We're just going to go opposite. So we're going to start with 1/2 minus 1/2. Well, they have the same denominator, so we can subtract. What's 1 minus 1? And we're left with 0/2. And this just means 0. Now we're going to go to our wholes. We have 3 minus 1. It's very simple, just bring it down. 3 minus 1 is 2. And right, our last step is to combine. We have 2 wholes over here and 0 over here. So our final answer is just 2 cookies for Joseph. That's very sloppy. And that's our final answer. Joseph ate 2 cookies. Let's try one more together. Let's start by reading the problem. James spent 3 2/3 hours playing video games. Aaron played games for 5 4/5 hours. What is the total time they played video games? Right, let's go back and annotate. James spent 2 2/3 hours playing video games. Playing video games is the action. Aaron played video games, another action, for 5 4/5 hours. What is the total time they played video games? What is our question asking us? That's right, total time they played. So that's going to be our title. That's what we're trying to figure out. Let's take down our information that we know. James played for 3 2/3. Aaron played 5 4/5 hours. We are looking for total time spent playing video games. So when we see total time, we know that we should do what operation? That's right, we're going to add. We're finding the total amount of time they played. So we have 2 mixed numbers. We want to add them. Let's think about our steps for adding mixed numbers. We're going to start by decomposing these fractions, or mixed numbers. So 3 2/3 is really 3 plus 2/3. And 5 4/5 can really be said as 5 plus 4/5. We're going to start by separating our whole numbers. We have 3 and 5. We add those together. We end up with 8. I'm going to leave this off to the side. We're going to find our fractions now. 2/3 plus 4/5. Okay, I notice that my denominators are not the same, so I cannot add those. We need to go back and do a little extra work and change those denominators so they're the same. So we're going to list our multiples of 3 and 5. 3, 6, 9, 12, 15, 5, 10, 15. And there it is. Common multiple is 15. So we're going to take each of these numbers, and our new denominator is going to be 15. We're going to write it to the side this time because we're running out of room on the bottom. How did we get from 3 to 15? That's right, we multiplied by 5. So 2 times 5 gives us 10. How do we get from 5 to 15? Multiplied by 3, so we're going to do the same to the top. 4 times 3 gives us 12. Now that we have a common denominator, we can add across the top. 10 plus 12 gives us 22 15ths. And as you notice, we're left with an improper fraction. So we're going to divide and change it into a mixed number. 22 divided by 15. I know that 15 can go into 22 only one time. When we multiply, we get 15. We're going to subtract 2 minus 5. I can't do, so I'm going to borrow. That turns into a 1. This turns into a 12. 12 minus 5 is 7. 1 minus 1 is 0. And our remainder is 7. So we're left with a mixed number of 1 and 7/15. That number cannot be reduced into anything simpler. So we're left with our mixed number over here. We need to remember that we have a whole number over here. And we need to combine or add again to get our final answer. I'm going to do it right in the space here. Seems like the best place to do it. I'll do it up top. So we have our 8 plus 1 7/15. We're going to combine our wholes. 8 and 1 gives us 9, and just carry the fraction over. So they spent a total of 9 hours, 9 and 7/15 hours playing video games. And that is our final answer. Alright, it is time for you to practice one on your own. Go ahead and solve the equation. Write your answer in simplest form. Chris rode his bike 3 1/4 miles on Monday and 4 3/4 miles on Tuesday. How much further did he ride on Tuesday than on Monday? Go ahead and annotate your problem, mark it up, and solve it. Pause the video, complete your work, and when you're done, come check in and see how you did. Great, let's see what you got. So you should have ended up with 1 1/2. Hey, you're going to start, it's a subtraction problem, so you're going to start by subtracting your fractions. 3/4 minus 1/4, well, it's 2/4. Then you're going to subtract your wholes. 4 minus 3 gives you 1. When you combine those two together, you have 1 2/4. And you should have noticed that 2/4 can be simplified. There's a factor that can go into both 2 and 4. So we're going to divide each number by 2 to get a easier, smaller fraction. And you're left with 1 1/2. I can solve problems involving fractions and mixed numbers. If you were able to keep up with the notes today and complete this last problem on your own, you have reached your target. If not, maybe go back and try some more practice problems. Remember that you need to annotate your word problems. You need to figure out if you're adding or subtracting. If the denominators are not the same, you need to create fractions with common denominators by finding the least common multiple before you add or subtract. And your last step is to reduce your fraction into simplest forms. That is it for today's lesson. Good luck on your problem set. As always, make sure you hit the submit button when you're done and look for feedback. Have a great rest of your day and a great weekend.